Welcome back, ladies and gentlemen. This is Dr. Robinson, and we are going to continue our studies. We're going to continue with part three of the percent change series that we started. And now we're going to what's called percent error. So, percent change, we're now talking about the percent error. All right, here's your vocabulary. Percent change we talked about before. It's the percent a quantity increases or decreases from its original amount. Whereas the percent error is the estimated amount differing from the actual amount. There's a formula that should be familiar to you in our other percent change video, but here's the percent error we're calling it. Percent error is equal to the absolute value of the amount, the measured amount minus the actual amount, and that's absolute value, divided by the actual amount times 100, and that'll give you the percent. So we're taking the differences between the measured amount and the actual amount, and we're going to make sure it's a positive number, and we divide it by the actual amount and multiply it by 100, and that'll give us our percent. If you remember in the other video, this was our percent change formula where we subtracted the original item and the new item and took the absolute value of that because we always wanted a positive number, divide that by the original item, and it's times 100, which gave us the percent. So you might want to check that video again to see how the formula was used. So let's go into a problem here. We have Imani estimates that a baby pig weighs 20 pounds and the actual weight of the baby pig is 16 pounds. We want to find the percent error. Okay, so the first thing we need to do is utilize our formula. So let me get a pen. So let's get a pen. Okay, choose a color. So we have the estimate, which is 20, and the actual weight, which is 16. So we're going to find the difference between those two. So let's subtract those two, and might as well get a calculator. So let me get my calculator. All right, 20 minus 16, and that is going to equal to 4. So let's bring that out there. So now notice the estimate minus the actual is going to be a positive number, 4, but we're going to divide that by the actual amount. So let's put a little division sign here, and let's put the actual amount, which was 16. So 16, we're going to divide that by 16. So now that we're going to divide that, let's clone that. So our fraction is going to be equal to 4/16. And we're going to multiply that by 100. So let's multiply that by 100. And let's bring that up there. And that'll give us our percentage. So calculator time. So let's put that back. Get my calculator. So 4 divided by 16 times 100, and that'll give us our percent. And there is our percent, which is 25%. So our answer is going to be 25%. And that's the percent error. So again, we take the absolute value of the estimate from minus the actual. We're going to divide that by the actual, and we'll have absolute value of 4, which is always positive, and that gives us 4 over 16, 4/16 times the 100, and that'll give us 25%. So here's one for you to try. So about David estimating the amount of songs he has on his cell phones. So he actually has 41 songs. So find the percent error to the nearest tenth. Oh, they want you rounded off to the nearest tenth of a percent. So remember, one decimal place after the point. All right, so hopefully you understand what's going on. If you don't, rewatch the video and check it out and write down your questions, bring them in tomorrow, and I'll be glad to answer them for you. Here's another one. Okay, we got a company fills bags with about 16 ounces of homemade dog treats. There's a little doggy down there. The acceptable percent error when filling the bag is 5%. So they're saying here that they have an acceptable amount, which is good, as long as it's 5%. If it's more than 5%, then they have a problem because that's too much. If it's less than 5%, then that's good. So, but it's got to be 5% or less. So they don't want to go over the budget because the bag might burst or something. So we want to find out whether uh, which bag, whether it be A or B, is acceptable. So here we have bag A. I know it says box A, but it's bag A. Has 15 ounces. So let's compare that. Let's get our calculator to help us out. So we're going to subtract the amounts. And remember, let's clear this. So was it 16? Okay, 16 ounces. All right, so we're going to subtract 16 ounces minus the 15. 16 minus 15, and it really doesn't make a difference if I subtract 15 minus 16 to get negative 1, but I know I'm going to get 1, so I get 1. Or I can just subtract 15 minus 16, and that'll give me negative 1, but I take the absolute value of that and still use the uh, positive value, which is 1. So I'm going to get 1. Now I got to put that over the amount that they want to actually have, which is 16 ounces. So my fraction is going to be 1 divided by 16. And I'm going to multiply that by 100. And that'll give me my percent. 6.25%, which will be the first one. So 6.25%, which would be this one. So is that acceptable? Well, remember they said they don't want to go over 5 ounces, 5%, I mean. So that's way over 5%. So that's a little bit too much. So this one is not acceptable. So sorry if you picked box A or bag A, that's no good. It's not acceptable because 6.25% is greater than 5%. So let's look at B. So let's get our calculator again and clear it. Let's subtract what this bag has, or box B, has 16.5, and we're going to subtract that from the actual amount that they want, which is 16 ounces, and that'll give us 0.5. Now we're going to take 0.5 and divide that by the original amount that they want, the actual amount that they want, which is 16. So they want 16 ounces. And remember, we got to multiply that by our magic number, which is 100. So we can change that to a percent. And that'll give us 3.125%. And that we'll put over here. Shrink that a little bit. Now let's see if that is acceptable. Now remember, they said you can go up to 5% as an error. So if it's over 5%, that's too much. If it's under 5%, that's fine. So this is less than 5%. So this bag, box B, is fine and acceptable. So we can accept box B. And here's our work to show that it is acceptable. 3.125% is acceptable because it's less than 5%. So we should adjust that and make that a percent. Okay. All right. So if you pick box B, box B is acceptable. Good work. So that was a good question. So go over the work. It's pretty much the same formula as we did before, the percent change formula. So try it If you got questions, write it down. I hope you understand what's going on. Here we got another question for you. We have some cereal this time. So take a look and see which one is acceptable, box A or box B. Captain Crunch, one of my favorite cereals. So give it a shot. I hope you understand what's going on. If not, watch the video again, write down your questions, bring them in, and we'll go over it in class. Here's Sabrina. She has marbles, and we want to find out uh, her percent error as well. So round it off like also to the nearest percent. So I hope you enjoyed the video. I hope you got something out of it. And remember, write us on YouTube and check out our other videos. There's our Dial a Teacher Homework Helpline at 212-777-3380, Monday to Thursdays, 4 p.m. to 7 p.m. You can dial those nice teachers. They'll be glad to help you out. My YouTube name is Dan Robinson. Check us out. Our latest math movie is PKMS Math Prep 19. And subscribe to our channel. Give us a thumbs up. Let us know how we're doing. You can tweet me at drobmath1. Don't forget to watch our show Math Time on Tuesdays from 4:30 p.m. to 5 p.m. on Optimum Cablevision, Channel 15. I think you'll like it. See our teachers and our fellow students. If you want to study with me or would like a copy of the worksheet on this topic, you can write me at robinsonmath@aol.com. I'll be glad to help you out. Don't forget our latest release coming out soon, Math Prep 20. So this is Dr. Robinson signing off. Hope you enjoyed the video. Bye-bye.